Welcome to BKW Physics. I'm Mr. McConley. We're going to talk about a potential and kinetic energy demonstration today. And what I want you to notice here, it's partially set up right now, is that this block is higher. It might be hard to see on the video. It's a little bit taller than the other block. So what I have, basically, is just a slight ramp. So when I put the ball here, the ball's going to roll down. The ball has some potential energy here based on its height. The potential energy is mgh, based on its mass, gravity, and the height off the table. So, because of that, by the time it gets down to here, it has a predictable amount of kinetic energy. And what should be true about the potential energy here compared to the kinetic energy here?
Same.
It should be the same. Okay, fine. That's not really the demo, but that's just some background. What the demo involves is, what if I change the shape to get it there? And we've done something like this already a little bit, so maybe you can predict what's going to happen. But this is even a little more tricky than the other one, because now I have these two identical metal spheres are going to start at the same elevation, they have the same potential energy, they're going to end at the same elevation, they have the same potential energy, so the kinetic energy has to be the same, right? It's got to be, besides maybe some small frictional forces. But what's going to happen here? Which one of these is going to win? Where you got a ramp, then this ramp comes back up. What do you predict? What's your call? This is like the Dukes of Hazzard, high, low, low road. Did you ever see that on Dukes of Hazzard, or is that show too old?
No.
No, I've seen it, yeah. The police car goes one way, the Dukes of Hazzard goes the other way. So which is better? Want to just see it?
Well,
so be it. There we go.
Wow.
Right.
Got it in class last time.
Okay, so sort of like the other demo, what happens sooner on this ramp?
Speed is it's accelerating.
You get a big acceleration right there. So you get a big acceleration for a short period of time. This one gets going really fast. But then you kind of think that that should get canceled out because it rolls back uphill. And now at this point, these are both matching height again. So do you think that the acceleration gained here gets lost on this side?
Not all of it, obviously, because it was still fast.
Well, let's see then. I want you to pay attention to the speed the ball's traveling here compared to the speed the other ball's traveling here, and let's see if they're the same speed or different speeds, okay? Maybe that'll help us. What do you think? They're not there at the same time. What do you think?
Looks about the same.
They are the same.
Yeah.
In fact, these, if you could line them up, you know, they get too far separated, but if you can line them up, they're both rolling at the same speed on that part of the ramp. So whatever you gained here, you lost here. So why does this one still finish so much faster?
It's going over the
But you gained it here and you lost it here, seems like it should cancel out.
Because if it canceled out, it'd stop rolling.
Yeah, if it totally canceled out, if like you went totally canceled it,
It's still pitched
it would
down.
be like if this came up a little bit
Go
higher.
back into the thing.
Yeah.
Like what if we put it backwards? Oh, what's gonna happen now? Still works the same way.
Because it's tilted down.
Because it's tilted down. So what if these blocks are the same height? What if this block and this block were the same height? Now what would happen?
It should.
Well, it wouldn't roll, right? It would just sit there. But if it was rolling and it got to here, basically,
It was pretty close.
see what I mean? I almost got it right. I was just guessing, but it almost just stops it, right? So the whole reason, back to what you were saying, is that that's the way we did it. You accelerate and you gain a bunch of speed. Yeah, you lose the speed, but you don't go back to zero. You only lose the speed back to what you should have been anyway. And then you continue on, but you've already gotten so far ahead, you win. So this has applications when you're sledding down a hill. If the hill is like smooth as you're sledding down, you know, really then it's just kind of an even competition. But if there's part of the hill that drops off quickly, then kind of levels off, and then continues down, you want to go on the part that drops off quickly in the beginning, because you'll get ahead of everybody, you'll beat them down the hill. For today, physics.